Okay, so let's consider the following example. So suppose we have a square matrix such that A times A transpose equals to A. Then prove that A is symmetric. Okay? So proof. Now we could use matrix multiplication. We could write A explicitly as an n by n matrix or a 2 by 2 matrix. I'd like to assume this is n by n. But in general, it's better to use properties of matrices. So first of all, what's the most important thing in this problem? Understanding what is the meaning of symmetric. Okay, so we have to prove that if we apply transpose to A, then we get A back. That's what we have to prove. And let's state a useful fact. So useful fact. If you have two matrices, A and B, and you take their transpose, let me rewrite this just a little bit clearer. So the transpose of AB is B transpose times A transpose. And notice if I were to write A transpose B transpose, in many cases the multiplication itself is meaningless. So let's see if this useful fact can help us. So let's start out with A transpose. Well, we know that A is equal to A transpose, right? So we can substitute. So let's substitute that. We have A transpose. And we have this outer transpose over here. And now using this useful fact or useful theorem, we get A transpose, right? So this is playing the role of the B over here, times A transpose. Now I didn't mention, but another useful fact is if you apply transpose twice, you get the matrix back. So that gives us A times A transpose. Oh, but wait, that's familiar. That's exactly A. And we're done. Right? We've proven that A transpose equals to A. And that's it. So we've shown that A transpose equals to A. In other words, A is a symmetric matrix. In other words, A is a symmetric matrix. So have an amazing day and happy linear algebra.